Hello everyone, this is a very beautiful question of the Newton's laws of motion. We have a wedge here having the mass capital M. This wedge is pulled horizontally by an external force capital F such that this block of mass small m neither slides down the incline nor up the incline. Actually, entire system moves only horizontally. Okay. Then we have to find the value of f such that out of these four choices, only one option is correct. And it is given that all these surfaces are smooth. It means we are considering no frictional forces. Okay. To solve the question, we'll be using the Newton's second law. Draw the free body diagram of the small m first. So you will show here the gravitational pull mg like this. And then this wedge will push it. That force we show as the normal force. These two are the external forces on this block having mass small m. At its center of mass we show the mg, and then there is a push by the wedge on the block which we show as the normal force. Okay, the normal force always makes an angle of 90 degree with the surface. Now we are going to do the two perpendicular components of the normal force. So one component of normal will do in this direction, another component of normal will do in this direction, horizontal and vertical. Because the system has the acceleration in the horizontal direction. The entire system is accelerating horizontally. Okay. To do the components will require the angle. This angle is theta, then this should also be theta. You remember the alternate angle, draw two parallel straight lines, and then if this angle is theta, this must be theta. So this is theta. Now here, this angle should be what? 90 degree minus theta, this angle. Because the normal makes an angle of 90 degree with the surface. Now you can check the total angle is 90 degree. Now this total angle is again 90 degree, this one I am talking about. Now, this angle must be then theta here. This angle here should be theta. So, if you do the component of the normal force, the component along the vertical direction would be n cos theta. The component along horizontal direction would be n sin theta. Now, we apply Newton's second law on m. Apply Newton's second law on m, the mass small m, along vertical direction. So we remember the Newton's second law. The net external force is equal to mass times acceleration. You remember that F net is equal to mass times acceleration in the vertical direction. And here we write net external force. How much is the net external force on this small m in the vertical direction? It's pretty easy. N cos theta minus mg is equal to mass times the acceleration in the vertical direction. There is no acceleration in the vertical direction. This entire system has acceleration only in the horizontal direction. So this A vertical is actually 0. So putting here 0. This gives us n cos theta is equal to mg, or we get the value of n if required. In this question, if someone asks us n, then it would be mg by cos theta, although it is not asked here right now, but this could be another good question. Now, apply Newton's second law on m along horizontal direction. Apply Newton's second law on small m along horizontal. So Newton's second law says the net external force is equal to mass times acceleration. How much is the net external force along the horizontal direction on small m? It is n sin theta. So let us write here n sin theta is equal to m times acceleration along the horizontal direction is a only. The entire system is being accelerated only horizontally. Okay. Now you call it equation number 2. If we divide equation 1 and equation 2 will get the value of A. What I mean to say, let us do 2 by 1, equation 2 divided by equation 1. Then we will have n sin theta by n cos theta is equal to ma by mg. Equation 2 is this, n sin theta equal to ma. Equation 1 is this, n cos theta is equal to mg. When you divide them, n getting cancelled out, m and m getting cancelled out. Sin theta by cos theta is tan theta. So your A comes out to be, via this calculation, you can write that the A comes out to be g tan theta. This is another nice data or question. If someone asks you how much is the acceleration, the horizontal acceleration of this system, the answer should be g tan theta. Now, apply Newton's second law again on this system. What we are calling a system? This mass capital M and the mass small m together. We consider this as our system. And on this system, we apply Newton's second law in the horizontal direction to obtain this force. So let us write that here. Apply Newton's second law on system along horizontal So in horizontal direction, the net external force is capital F only. So that capital F will be the mass of the system into the acceleration of the system. Mass of the system is capital M plus small m, and the acceleration of the entire system is small a. The value of small a is already with us. It is g tan theta. So m plus m, and when you replace the value of that small a, you can write here g tan theta, and it matches with the third option. So it is the correct answer. I hope you enjoyed this solution. If you enjoyed it, please like this video, share it with your friends, and kindly subscribe to this channel. Stay awesome and thank you. And if you have any other doubt, kindly post that in comment box. We'll discuss that.